Chapter 1: The Forbidden Fire. Welcome to Synapse Daily. Today, we are walking through the graveyard of a future that never was. January 1970. The air in Washington, D.C. was heavy with the scent of cheap tobacco and the cold realization of a fading decade. While the public was still mesmerized by the grainy black and white footage of Neil Armstrong, a silent execution was being performed in the Rayburn House office building. A bureaucratic pen stroke officially cancelled Project Orion. This wasn't just a budget cut, it was the moment humanity decided to cage itself. To understand Orion, you must visualize a ship that defies every law of modern rocketry. This wasn't a slender, fragile needle of aluminum. Orion was a 4,000-ton dreadnought, a Gothic cathedral of steel and lead. It didn't use liquid oxygen or hydrogen. It lived on a diet of atomic fire. It was designed to launch from the Jackass Flats in Nevada, sitting atop a massive, machined steel pusher plate. Underneath that plate, a vending machine-style mechanism would eject a nuclear pulse unit every second. The explosion would slam into the plate, the plasma would expand at speeds beyond human comprehension, and the ship would lunge toward the stars. We are talking about the most violent propulsion system ever conceived, handled with the precision of a Swiss watch. Why did we walk away from the keys to the solar system? Today, we peel back the lead shielding on the dream that was too big to live. Chapter 2: The Put-Put, when the dream first took flight. Point Loma, California. 1958, the sky was a perfect, deep blue. The Pacific Ocean crashed against the rocks below. It was a place of peace. But Ted Taylor and Freeman Dyson were about to break that peace. They stood behind a thick sandbag wall. They held their breath. In front of them sat a strange object. It was a 3-foot-tall steel craft. It looked like a heavy, upside-down mushroom. They called it Hot Rod. It had no fuel tanks. It had no glowing wires. It just had a thick steel plate at the bottom. And a pile of TNT charges. Firing in 3, 2, 1. A deafening crack ripped through the air. A cloud of black smoke erupted. The little steel ship jumped. It wasn't a smooth liftoff. It was a violent kick. Then another crack. And another. Crack, 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 crack. The ship didn't tumble. It didn't spin out of control. It climbed. It rode the explosions like a surfer rides a wave. It hopped higher and higher into the California sky. 6 pulses. 10 pulses. The rhythm was perfect. It was a heartbeat made of high explosives. Dyson watched through binoculars. His heart was pounding. He wasn't seeing a toy. He was seeing the future of the human race. He saw a way to bypass the limits of chemistry. He saw a ship that could ignore the laws of weight. If TNT could lift the steel mushroom, the atom could lift a city. The Put-Put tests proved it. The dream was no longer on paper. It was flying. Chapter 3: The Physics of Impossible Speed and the Graphite Veil. Let's talk about the numbers, because the math is where the tragedy of 1970 truly resides. In rocketry, we measure efficiency by specific impulse, or $I_SP, dollar. The Saturn V, the pinnacle of chemical engineering, has an $I_SP, dollar of about 450 seconds. That is the hard ceiling of chemistry. Project Orion started its calculations at 2,500 seconds and reached as high as 100,000 for Interstellar versions. The engineering was a masterclass in brute force elegance. The pusher plate, the most critical component, faced a terrifying problem: vaporization. How do you stop a nuclear explosion from melting your ship? The solution was ingenious. Before every explosion, a thin layer of graphite oil would be sprayed onto the plate. The nuclear plasma would hit the oil, turning it into gas. This ablation absorbed the heat, protecting the steel. Then came the shock absorbers. To prevent the crew from being turned into jelly by the 10,000 G kicks of the explosions, they designed a 2-stage system of massive gas-filled bellows. These springs would smooth out the violent pulses into a steady, comfortable 1G push. You could have stood in the middle of the ship and poured a glass of wine while 500 atomic bombs detonated beneath your feet. It was the ultimate paradox, using the most chaotic force in nature to create the most stable ride in history. Chapter 4: The 1970 Murder of a Future. January 1970. Washington, D.C. was freezing. The wind whipped through the gray streets. Inside the halls of power, the air was stale. It smelled of old coffee and wet wool. There were no cameras here. There were no cheering crowds. Just men in gray suits. They looked at the budget for Project Orion. They saw a number. It was a big number. But they didn't see the stars. They saw the Vietnam War. They saw a burning treasury. They saw a public that was terrified of the word nuclear. One man picked up a pen. He didn't look at the blueprints of the Mars colony. He didn't look at the designs for the Saturn base. He looked at the political risk. The partial test ban treaty was a wall. Crossing it meant trouble. It meant talking to the Soviets. It meant explaining black rain to voters. He signed the veto. The ink was black. It was cold. That single line of ink did more than stop a rocket. It erased a timeline. It closed the door to the solar system. The engineers at General Atomic got the call. It's over. They didn't argue. They didn't scream. They just turned off the lights. They put the models in crates. They walked out into the cold January air. Humanity had just decided to stay in its cradle. The stars were now officially too expensive. Chapter 5: The Dreadnought, a Fortress in the Dark. Before it was killed, Orion had a brother. A dark, terrifying brother. The U.S. Air Force wanted a battleship. They didn't want to explore. They wanted to rule. They imagined a ship made of thick, black steel. It was 500 feet long. It had no windows. It had no thin hull. It was an armored tank in orbit. They called it the Project 797. It was designed to survive a direct nuclear hit. In 1961, they took a model to the White House. President John F. Kennedy sat at his desk. The military men opened a suitcase. They showed him a ship that could hold 200 nuclear missiles. They showed him cassava howitzers. These were cannons that fired beams of nuclear plasma. They could melt a city from 1,000 miles away. Kennedy looked at the model. He felt a chill in the room. This wasn't a ship of peace. This was a star of death. He realized that if the US built Orion, the Soviets would build their own. The sky would be filled with nuclear fortresses. The moon would become a missile base. This was the secret reason for the 1970 cancellation. It wasn't just the money. It wasn't just the fallout. It was the fear of the monster Orion could become. We were a species that couldn't be trusted with a starship. We were too violent. We were too hungry for power. The Air Force wanted a sword. Congress decided to break the sword before it could be forged. But in breaking the sword, they also broke our wings. Chapter 6: The Vending Machine of the Gods. Step inside the engineering bay. Look at the Pulse unit. This is the heart of Orion. It is the most dangerous object ever built. It is an atomic bomb. But it is built with the precision of a diamond. Imagine a massive steel tube. It runs through the center of the ship. It is like a giant vending machine. At the top sit thousands of pulse units. Every second, one unit drops. It falls through a hole in the pusher plate. It clears the ship by exactly 100 feet. Then, the universe screams. The unit detonates. It is a mini-star. A white-hot flash. It creates a temperature of millions of degrees. But the energy isn't wasted. A slab of polyethylene plastic sits inside the unit. The radiation hits the plastic. In a microsecond, the plastic becomes plasma. It becomes a jet of fire. This plasma jet moves at impossible speeds. It slams into the pusher plate. The plate is 2 feet of solid steel. It groans under the weight of the sun. But it doesn't melt. Why? Because a thin veil of graphite oil protects it. The oil vaporizes. The steel stays cool. The ship lunges forward. The massive gas-filled shock absorbers compress. They absorb the blow. Then they push back. The ship smooths out the violence. Inside the cabin, the astronauts feel a gentle tug. They are riding a series of nuclear sunrises. It is the most efficient engine ever designed. It is raw power, tamed by a thin layer of oil and a giant spring. Chapter 7, The Interstellar Dream. Scaling to the 8 million ton Starship. As the 1960s progressed, Freeman Dyson began to look past Mars. He began to look at Alpha Centauri. This is where Orion transitions from a rocket to a world ship. Dyson calculated that if you scaled the technology up, the physics actually became more efficient. He proposed the Super Orion. We aren't talking about a 4,000-ton ship anymore. We are talking about a vessel weighing 8 million tons. It would be 10 kilometers long, a literal floating city in the void. For fuel, it would use hydrogen-triggered fusion pulses. Dyson calculated that such a ship could reach 3% to 5% of the speed of light. At those speeds, humanity could reach the nearest star system in roughly 130 years. It would be a generation ship where the children of the original crew would be the ones to step onto an alien world. The blueprints for this ship included vast internal forests for oxygen recycling and shielded centrifugal rings for artificial gravity. In 1968, this wasn't considered a fantasy, it was considered a difficult, yet solvable, engineering problem. But as the Super Orion grew in the minds of the scientists, the political will on Earth was shrinking. The gap between what we could do and what we were allowed to do was becoming a canyon. Chapter 8, The Great Classified Silence and the Final Veto. By 1969, the momentum for Project Orion was dying a death of 1,000 cuts. The primary assassin was the Partial Test Ban Treaty, PTBT. This international agreement banned nuclear detonations in the atmosphere and in space. It was a victory for the environment, but it was a death sentence for the nuclear Starship. The project leaders tried to pivot. They suggested building the Orion in orbit, using a fleet of Saturn V rockets to carry the components. They suggested using cleaner bombs with less radioactive fallout. But the Bureau of the Budget, led by men who saw the moon landing as the finish line rather than the starting gate, refused to listen. In January 1970, the Nixon administration officially removed the final line item for Orion from the budget. The engineers were told to pack their bags. The models were moved to secret warehouses. The men who had spent a decade calculating the trajectories to the moons of Jupiter were suddenly unemployed or reassigned to build more efficient ways to destroy cities on Earth. The Great Silence began. For the next 50 years, Project Orion would exist only as a ghost in the National Archives, a reminder of a time when we were willing to be dangerous to be great. Humanity didn't just lose a ship in 1970, we lost the nerve to leave our cradle. Chapter 9, The Ghost of Wernher von Braun and the Chemical Rivalry. While Project Orion was fighting for its life in Congress, it was fighting another war within NASA itself. This was a battle of philosophies. On one side, you had the nuclear revolutionaries, Dyson and Taylor. On the other, you had the chemical king, Wernher von Braun. Von Braun was the architect of the Saturn V. He was a master of liquid-fueled engines. To him, space travel was a delicate ballet of precise chemical burns. Orion, by contrast, was a barroom brawl. It was loud, dirty, and unimaginably powerful. Von Braun initially dismissed Orion as propulsion by firecracker. He feared that if Orion succeeded, his beautiful, slender Saturn rockets would become obsolete overnight. Why build a complex, multi-stage chemical rocket to carry a tiny capsule when a nuclear pulse ship could carry a literal building? This rivalry created a fractured NASA. The agency was terrified that Orion's radioactive reputation would ruin NASA's public image. They wanted the all-American glow of the Apollo program, not the gritty, fallout-heavy reality of nuclear propulsion. In the end, the traditionalists won. We chose the elegance of the Saturn V over the raw, unbridled power of the atom. We chose the path of the needle rather than the path of the hammer. Chapter 10, The Ensman Starship, Living in the Deep Void. As the interagency fighting continued, some engineers were already looking 100 years into the future. This led to the creation of the Ensman Starship, the most famous variant of the Super Orion concept. If the 1970 cancellation hadn't happened, this would have been humanity's first world ship. The Ensman Starship was a gargantuan concept. It featured a massive spherical fuel tank at the front, filled with 3 million tons of frozen deuterium. Behind this snowball was the crew habitat, a series of cylindrical modules that could house 200 people in total comfort. This wasn't a mission, it was a migration. The ship would utilize fusion pulse propulsion, a more advanced version of the Orion system. By detonating fusion pellets instead of fission bombs, the exhaust velocity would be high enough to reach a significant fraction of the speed of light. The Ensman design addressed the psychology of the void. It included internal parks, artificial lakes, and shielding so thick that the crew would be safer from cosmic radiation than people standing on the surface of Mars. It was the blueprint for a Type 1 civilization. But when the funding was slashed in 1970, the Ensman Starship went from an engineering goal to a science fiction ghost. Chapter 11, Medusa, the spiritual successor to the Pulse. Even after the 1970 execution, the logic of nuclear pulse propulsion was too strong to stay buried. In the 1990s, the Medusa concept was born as the spiritual successor to Orion. If Orion was a pusher, Medusa was a puller. Instead of a heavy steel plate, Medusa uses a massive, parachute-like sail made of high-strength carbon fibers. The sail is kilometers wide. The ship ejects nuclear charges ahead of itself into the sail. The explosion expands, catches the sail, and pulls the ship forward. This solved one of Orion's biggest problems: weight. By replacing a 1,000-ton steel plate with a lightweight sail, the efficiency tripled. Medusa represents the cleaner evolution of the Orion dream. It was designed to be built and launched strictly in deep space, far from Earth's atmosphere, eliminating the fallout concerns that killed the original project. Yet, the stigma of the N-word, nuclear, continued to stall the project. We have the technology to reach Pluto in months using a Medusa-class ship, yet we continue to spend decades sending slow, chemical probes. The shadow of 1970 was long, and it covered every nuclear breakthrough that followed. Chapter 12, The 10 Deaths and the Scale of Justice. Let's talk about the ghost that haunted Freeman Dyson. It was a number, 10. Dyson was a man of peace. He hated the bomb. But he loved the stars. He sat in his office with a slide rule. He calculated the fallout of an Orion launch. If a 4,000-ton ship launched from Nevada, it would poison the air. Small particles of radioactive debris would enter the atmosphere. They would travel around the world. They would fall with the rain. They would enter the soil. Dyson calculated that statistically, this would cause 10 deaths. 10 people. Somewhere on Earth. They would never know why they got sick. They would never know that their lives were the fuel for a starship. This was the moral weight. Congress used this number as a weapon. They called it unacceptable. But look at the other side of the scale. Every year, thousands die in coal mines. Thousands die in oil wars. Thousands die from car exhaust. We accept those deaths for comfort. We accept them for heat. But we wouldn't accept 10 deaths for the universe. We demanded a clean path to the stars. But space is not clean. Space is a radiation-soaked vacuum. By saving those 10 lives in 1970, did we condemn millions more? Without the resources of space, we fought over the resources of Earth. We stayed in the mud to keep our hands clean. Was it a moral victory? Or was it a failure of courage? The 10 ghosts of Orion are still watching us. They are waiting for us to decide what the future is worth. Chapter 13, The Modern Landscape, Starship vs. The Ghost of Orion. As we stand here in 2026, we are witnessing the greatest age of chemical rocketry in history. We see SpaceX's Starship, a stainless steel tower that captures the imagination of millions. It is, by all accounts, a masterpiece. But if we place Starship next to the 1970 blueprints of Project Orion, the difference is humbling. Starship is an exercise in extreme optimization. It squeezes every possible ounce of energy out of methane and oxygen. Yet, to send a Starship to Mars with a significant payload, you need to launch it, then launch 10 more tanker ships to refuel it in orbit. It is a logistical marathon. Project Orion, by contrast, was a sprint. An Orion-class ship wouldn't need a tanker. It wouldn't need a refueling depot. It would simply ignite its pulse units and arrive at Mars in 90 days with enough cargo to build a small city. The tragedy of our modern era is that we are perfecting a technology, chemical combustion, that hit its physical limits decades ago. NASA and DARPA have recently begun dusting off the Orion files for a project called Draco, Demonstration Rocket for Agile Cislunar Operations. They are looking at nuclear thermal propulsion, which is a softer cousin of Orion. It's as if we are finally admitting that we cannot conquer the deep dark with fire and ice alone. We are slowly crawling back to the atomic dream that we abandoned in 1970, realizing that the slow path might actually be a dead end for a multiplanetary species. Chapter 14, The 2026 Alternate History, The World That Was Robbed. Let's indulge in a thought experiment. Imagine that in January 1970, the US Congress didn't sign a veto. Imagine they signed a blank check. What does our world look like today, on January 23, 2026? In that timeline, the first Martian War of Independence might already be a chapter in history books. By 1980, the first Orion city would have landed in the Valles Marineris. By the year 2000, we wouldn't be debating whether to send humans back to the moon. We would be debating which of the 60-plus moons of Saturn is the best location for a new university. In a world powered by Orion, energy is no longer a scarcity. The technology required to build a ship that can survive a nuclear pulse is the same technology required to build near-limitless fusion power on Earth. We would likely be a post-scarcity civilization. The climate crisis of the early 21st century might never have reached a breaking point, because we would have moved our heavy industry, the mining, the smelting, the manufacturing, into the asteroid belt. Instead of looking at our phones and seeing a world divided by borders, we would look up and see the lights of passing pulse ships, connecting a solar system-wide economy. This is the opportunity cost of 1970. We didn't just lose a rocket, we lost a version of ourselves that was bigger, bolder, and more united by a common frontier. We chose to stay in the cradle, and as a result, the cradle is getting crowded. Chapter 15, The Final Verdict, Writing the Forbidden Fire. As we close this deep dive on Synapse Daily, we have to face a hard truth. Project Orion was dangerous. It was radioactive. It was a weapon of war repurposed for peace. It represented a version of humanity that was willing to play with the forbidden fire of the gods. The 1970 cancellation was the moment that adults in the room decided that humanity wasn't ready. And perhaps they were right. Perhaps a species that still fights over lines in the sand shouldn't have the power to move 8 million-ton ships through the heavens. But the cost of that safety has been 50 years of stagnation. The blueprints for Orion are still there. They are sitting in the National Archives, waiting. They are a reminder that the only thing stopping us from reaching the stars is a signature and a choice. We have the math. We have the physics. We have the materials. All we lack is the nerve. Will we ever see a nuclear pulse ship ignite its engines in our lifetime? Perhaps not. But as we look toward the 2030s and the looming threats to our planet, from climate change to resource depletion, the Star Eater looks less like a monster and more like a savior. We may eventually find that to save the Earth, we have to be willing to leave it on a pillar of fire. Thank you for joining us for this marathon journey through the classified history of Project Orion. This wasn't just a story about a cancelled project, it was a story about who we are and who we chose to be in 1970. Like this video if you learned something new. Did the government make the right choice, or did they rob you of a future in the stars? Comment your thoughts below, we read every single one. And if you want more deep dives into the forbidden tech and hidden histories that shaped our world, subscribe to Synapse Daily and hit that notification bell. Don't let the fire go out. We'll see you in the next episode.